So these are problems from the notes we just took about rectangles, squares, rhombuses, okay? So the information we're going to use is from those last pages we did, okay? So we have a rectangle form. FR is 2x plus 1, so this diagonal, 2x plus 1, and AM, the other diagonal, is 5x minus 5. So let's find x and find the measure of each diagonal. We have a rectangle. So what information about diagonals do I know about a rectangle? If you don't know, diagonals are congruent. So if you look back at the rectangle page, so diagonals are congruent, they're equal, right? So we can take these two expressions and set them equal to each other. So I have 2x plus 1 equals 5x minus 5. So now we just solve for x, so let's get our x's on the same side. So minus 2x, we'll move the smaller one. So I have 1 equals 3x minus 5. Add 5 to both sides. So 6 equals 3x, and divide by 3x equals 2. So again, x is 2, that's for x, and they want to know the measure of each diagonal. How do I find the measures of the diagonals? Plug in 2, yeah, for x. So it doesn't matter which one you plug it into, you should get the same measure for both. So 2 times 2 plus 1, so 4 plus 1, 5. So each diagonal should be 5. So AM is 5, FR is 5. So that was the rectangle. On the next page, so we have cows is a rhombus. So you can see these measures. WS is 9. We'll just write it in there. CM 3.4. So fill in what we know. And the measure, this should be angle MCO. MCO, so this top angle here, this angle measure here is 66 degrees. Okay? So again, remember, turn back to rhombuses if you're not sure. Right, it's right in the middle of your page. Okay? Let's start with these sides. What do I know about the sides of a rhombus? What makes a rhombus? What is it about a rhombus? 4 congruent sides. So these sides, because it's a rhombus, I know all sides are congruent. So 9, 9, and 9, right? So CO is 9, OW is 9, and CS is 9. All sides, right? So the next thing we have here is CW. It's part of a diagonal. What do we know about the diagonals of a rhombus? Diagonals do what? Diagonals bisect. So again, that means these two are the same, right? I'll put 2. Because that segment is cut in half. So this bottom, if the top is 3.4, the bottom's got to be 3.4, right? Which makes the total what? 3.4 plus 3.4, which is 6.8. Good. So that's your diagonals. Now, what do we know about the angles of a rhombus? All right, so one thing we do know about these diagonals is they connect and form 90 degrees, right? So we have 90-degree triangles here, right? So if this angle is 66, the middle's 90, what's the top angle over here by O? So we have a 90, we have a 66, and then the third angle would be what? 24. So remember, all those add up to what? Triangles add up to 180, right? So 180 minus 90 is 90. Minus 66 leaves me with 24. So this top angle over here is 24. Okay. What else? Anything else we know about the rhombuses? The diagonals of the rhombus? Well, perpendicular at 90 degrees, and what? What's the other one? The other fact that we have in there. There's two of them with diagonals. Diagonals blank the angles, and in a rhombus the diagonals are blank. Bisect. Is that what it is? Bisect? So what's it mean to bisect the angle? Man, we're talking about an angle now. So if I bisect an angle, I'm cutting it in what? Two equal parts, right? So if this is 24, what's the other part? 24. If this is 66, what's the other part? 66. So what's 24 and 24? 48. So angle O is 48. What do I know about the opposite angles? Opposite angles are congruent. So if O is 48, S is 48. And if C is 66 and 66, what's that give me? What's 66 and 66? One what? 66 plus 66. 132. So C is 132. What's W going to be then? 132. And then what's CMS? What's this angle inside? What did we say it was? 90. Alright, so that's that rhombus. On the next page. Okay, so on the next page. So we have a quadrilateral, 4 sides, right? There's the vertices. It says determine whether PQRS is a rectangle. Okay? Now, what's specific with a rectangle? So if you go to rectangle, what's specific about a rectangle? 4 right angles. 4 right angles and? You can wait till the end. I'll get you. 4 right angles and? Congruent. Opposite sides congruent. So, the slope formula, okay, is going to tell us if our sides or angles are 90 degrees, perpendicular, right? So let's take a look at our slope. So from S to P, rise is 3 over 2, right? So 3 over 2, right? Let's take a look at the other side. 3 over 2. So those are parallel, right? Let's see if these sides coming into them are perpendicular to each other. So S to R, rise over run, down 1, 2 over 1, 2, 3. Down 2 over 3. So are these two sides perpendicular? Is angle S perpendicular? 3 over 2 and negative 2 over 3? Yes. So remember, perpendicular, opposite reciprocal. Or flip, right? We call that reciprocals flip. Oops. So 90 degrees. What about this side? Negative 2/3 and 3/2, 90 degrees? Yep, angle R is 90 degrees. So let's take a look at the second one then. P to X. So down 1, 2 over 1, 2, 3. So again, negative 2 to 3, right? So looking at angle P, 3/2, negative 2/3, that's 90 degrees. And angle Q is 90 degrees. So all angles are 90. So that's part of it, right? Now, what about the distance formula? What's that going to tell me? Equal what? Sides. And what sides need to be equal? Opposite, right? So, again, if I look at this, I can use this 3/2 here, okay, because I'm counting from point all the way to point to help find my distance formula, okay? Remember, distance formula is that change in X over change in Y, right? So change in X is 2, change in Y is 3. Does that make sense? So we can take that square root, 3 squared plus 2 squared. So what's 3 squared plus 2 squared? So 3 squared is 9, 2 squared is 4. What's 9 plus 4? Square root of 13. We'll just leave it as square root of 13. So this side is square root of 13, right? Let's check the opposite side. So again, what numbers do I have here? 3 and 2. So if I take those same numbers, what should I get? Same thing. So these two sides are congruent. Now let's check the other sides. Now again, I have to count from point to point. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So 6 and 4. So square root 6 squared plus 4 squared. That's our differences. So 36 and 16. What's square root of 30 or 36 plus 16? 36 plus 16 is what? 36 plus 16. What? 52. And we can just leave it as that, right? So check the S to R. So again, let's count. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4 and 6 again. So if we're using the same numbers, we're going to get the same answer, right? So we can see opposite sides congruent, opposite sides congruent. The angles, the slopes are opposite reciprocals, so that means my angles are all 90 degrees, and it proves that it's a rectangle. Okay? Questions on that? All right, I think there's one more problem before we have additional notes here. All right. So it says prove that a figure is a parallelogram. So go back to this page, parallelogram test. Those are the 5 ways to prove something is a parallelogram. Now, what's probably the easier ones to show? What's the easier one to show? Well, can we measure angles? I mean, we can, but kind of, you gotta use a protractor and it takes time, right? So probably not the angle ones, right? What about the distance formula? We can do that, but again, distance formula takes a little bit of time, right? What's the easiest one? Opposite sides are parallel, right? So let's use our slope. Okay. What number was that? Number one. So this is rule number one from those 5 rules that we had. Opposite sides are parallel. So we're going to use our slope to determine that. So let's look at AB. So AB, our slope here, rise up 1 over 1, 2, 3, 4, 5. 1/5 is our slope, right? Let's do our opposite side. So then DC here, slope up 1 over 1, 2, 3, 4, 5, 1/5. Yes, these are parallel to each other. Okay, those little arrows are meaning parallel, right? And then let's check our slope for AD. So now we have AD here. So rise over run. So down 1, 2, 3, 4 over 2. Down 4 over 2, which can simplify to negative 2 over 1. And then BC, down 1, 2, 3, 4 over 2. Negative 4 over 2, again simplifies. So are these two sides, AD and BC, parallel? Yes. So now I know those two sides are parallel, and we have a parallelogram. Both pairs of opposite sides are parallel. Okay? So that's the easiest one to check, just because you're just counting. Rise and run. Given the diagram, prove that the diagonals of a parallelogram bisect each other. Okay? Now, in one of the worksheets, we found the midpoint, right? So if I look, and if I find, if this is the midpoint for these points, that means it bisects it, right? Okay, so that's what we're looking for. So if I look at these points, so if I look at A, I have, so A is 1, 4. And if I look at C, C is 8, 0. So let's find the midpoint of those. So adding the x's and divide by 2. So 8 plus 1 divide by 2 gives me what? 8 plus 1 is 9. Half of 9 is 4.5. Add my y's. So 4 plus 0 divided by 2. Well, 4 plus 0 is 4. Half of 4 is 2. So 4.5, 2. So if I look at this point, 4.5, 2. Does it look like it's at 4.5, 2? Yep. So this side works, right? AC is bisected. Then do the same thing with BD. So if I look at B, point B is 6, 4. Point D is 3, 0. So again, adding them together, 6 plus 3. 6 plus 3 is 9. Half of 9 is 4.5. Add my y's together, 4 plus 0. Divide by 2, 4 plus 0 is 4. Half of 4 is 2. So 4.5, 2 is my second point. So that proves that these are bisected and AE and EC are the same. Okay. All right, questions on that? There. What's the relationship between parallelograms, rectangles, rhombi, and squares? Parallelograms, rectangles, rhombus, and squares. What is it? Okay, 4 sides, all 4 sides, right? All 4 sides. Anything else? Parallelograms, rectangles, rhombus, and square. Okay? All opposite sides are congruent. Anything else? All what? Opposite angles are congruent, right? Now, what's special with a square? Okay. What's special with a square? So, the square, all sides equal, all angles equal, right? What's a rhombus? All sides equal, right? What's a rectangle? All angles equal 90. And a parallelogram is opposite sides of parallel. So what do you know about a square? All sides are equal, which means it's a rhombus, right? Square, all angles are 90, which means it's a rectangle. And in a square, opposite sides parallel? Yeah, so it's a parallelogram. So a square is all. So a square is a rhombus, a rectangle, and parallelogram. Okay, so a square is all three. It says classify the figure as precise as possible, explain your reasoning. Now, I would start with the most specific one, okay? So, most exact. So which one is the most exact? Of our four options here, parallelograms, rhombus, rectangles, squares, which one is the most precise? Square. So let's take a look at that. 90-degree angles, congruent sides. So again, if I look at my sides, and I would go from point to point, right? What's my rise and run? 2 over what? So up 2 and over 2. Okay, so again, let's take a look. Does that distance, does that go up 2 over 2? So from 0 to 2, yep. 5 to 7, yep. 2 over 2. What about 5 to 7, 4 to 2? Yep. And what about the last one here? So, right, 0 to 2, and what? 3 and 2, right? So when I look at that distance formula, 2 squared plus 2 squared is the same for all of them, right? Does that make sense? Now when I look at that slope, so these distances are all the same. So all sides are the same. So it's either a rhombus or it's a square, right? Then I need to look at my angles. So this is a positive slope. Here is going to be a negative slope, positive slope, and a negative slope. So are those fractions opposite and flipped? Well, if I flip 2 over 2, what do I get? 2 over 2, right? Opposite and flipped, right? So then these angles are all 90 as well. So then I can say it is a square. 90-degree angles, congruent sides. And then, is there one more problem? So one problem here, prove the diagonals of a rhombus are perpendicular. So here's a rhombus. So if I do my diagonals, I have so from B to A, there's a diagonal. What's the distance from A to B? Or, I'm sorry, what's the slope from A to B? Slope of AB is what? Rise over run. Well, how much did I rise? From A to B? 3. How much did I run? What happens if 0 is in the bottom? Undefined. So it's an undefined slope. Now, what about my slope across? So now my slope across, so what's my rise? This time my rise is 0, so this is going to be D or CD. So my CD slope, my rise is 0. What's my run? It went from negative 1.6 to 3.6. Or just 4. So my run is 4, right? So my slope here is 0 on top, 0, right? Now, undefined slope and 0 slope, are they perpendicular? Yeah. Yep. So undefined and 0 slope is perpendicular.